Today we're going to be talking about infinite limits, and let's just use a picture to find each one of these infinite limits. So the limit of our function as we go to positive infinity. So as my graph goes to positive infinity, we're approaching, it looks like the line y equals -4. And as we go to negative infinity, looks like we are approaching also -4. So notice when we have x going from negative infinity and positive infinity, these tend to be a horizontal asymptote, or what I like to call the end behavior, because what you're talking about is as x gets really, really big and really, really small, what happens to our function towards the end. That's going to be super important to us. And now the other ones happens when we have a vertical asymptote. So as I go to 3 from numbers a little bit less, as I go into 3 from numbers a little bit less, looks like we're going up to positive infinity. As I'm going to numbers a little bit more towards 3, I'm going to negative infinity. So this limit, since those limits are not the same thing, I'm not going to one specific value. This limit at 3 does not exist. First part we're going to be talking about is horizontal asymptotes. And as I alluded to the last page, horizontal asymptotes happen. Horizontal asymptotes happen when you go to positive infinity and negative infinity, and they both approach the same line, or they both have the same end behavior. Okay, so use graph and tables to find each for our function. Now I have a graph here of the function, but you should be able to do this without a calculator because use everything that you know. Horizontal asymptotes, I've been telling you guys, is the same thing as end behavior. So recognize something that you should remember about rational functions from previous math classes. The power on the top is the same as the power on the bottom, so it's the ratio of the leading coefficients. So the horizontal asymptote is y equals 1. What does it look like our values are going to as I get more and more towards positive infinity? It looks like I'm going to 1. As I go to negative infinity, looks like I'm getting closer and closer and closer also to 1. So since these are both the same value, I do have a horizontal asymptote at 1. Finding a model for the end behavior of each. So finding a model is essentially a fancy way of saying an equation for the end behavior. What happens as these values get really, really big? So finding a model for the end behavior, you have to just look at kind of like what we did with horizontal asymptotes. Okay, so what is this going to look like at the very end? Well, we just worry about the highest power on the top and the highest power on the bottom. Highest power on the top is 2x to the 4th. Bring the coefficient with us. And on the bottom we have negative x to the 3rd. If I simplify that, I get negative 2x. So this function is going to look like the equation y equals negative 2x for the end behavior, or as the x's get really, really big. For the bottom one, again, look at the highest powers. So our end behavior is going to look like 7x to the 3rd over 3x to the 3rd. Those cancel, and you get 7/3 for our end behavior. Now finding positive and negative infinite limits and using limit laws to justify our answer. Okay, so first we're going to find our positive infinite limit. Now, since this function is a product, I can separate our limits out. So I'm finding the limit of that function, but I can find each one of these functions individually if I wanted to. And since I'm finding the limit of this individual thing, I can also separate the first part of our product into a sum of limits also. So that's one piece. And then now I have the other piece. Now again, let's look at this. Remember, infinite limits as x is going to positive and negative infinity, you're looking at asymptotes. So what happens to as x goes to infinity of this 4 over x? Well, that's going to be 0. Limit of a constant is the constant. Now we have this crazy function here. Well, this crazy function, remember, just look at highest power on the top, highest power on the bottom. That limit there is equal to 7 over 4 because that's what our horizontal asymptote would be. So therefore, this limit is equal to 21 over 2. Similarly, when I do infinite limits for negative infinity, I can also break it down the same way. And I'm going to negative infinity. I forgot my negative sign over here. Okay, so that's going to go, that first one's going to go to 0. The next one's going to go to 6. Again, look at your horizontal asymptote for this guy. Even though it's negative infinity, because the squareds go away, it's still going to be equal to 7/4, which is going to simplify to 21 over 2. Okay, use a table value to find each one of those limits. What I want you guys to do is I want you on your own, in your own calculators, to fill in these tables. I am going to pause the video and fill them out on my own, and I will be back in 1 minute. Hopefully you got some values that were very similar, but notice for each one of these functions, as your numbers got bigger and bigger, both of these went to 0. Now, the same thing is also true for negative infinity. So the limit as x goes to negative infinity of this function sine of x over x is also going to be 0. And the same thing also holds true for our cosine. The negative infinity limit is also 0. So keep these infinite limits in mind. Okay, find each limit for each one of these functions. So the limit as x goes to infinity of 2x plus the sine of x over x. Now you can separate out the numerator. What I mean by that is you can separate this out into 2x over x plus the sine of x over x. and then do each one of these limits individually. The limit as x goes to infinity of 2 is 2. We found this limit on the last page to be 0. So we are at 2. Now, because the same thing holds true as I go to negative infinity, the reason that happens is because this limit here, that's also going to be 2. This limit here is 0. So for either side, for positive infinity and negative infinity, our limits are both equal to 2. Now, vertical asymptotes. Vertical asymptotes of a function are when you're going to, instead of going to infinity, you're going to a certain value. We're going to a certain value, but you're going to positive or negative infinity for your y. So the function's getting infinitely big or infinitely small as you're approaching a specific x value. So finding the vertical asymptotes. Remember, that's when the bottom equals 0. So I'm going to set the bottom equal to 0. And then I'm going to factor that guy. And I'm not going to go through factoring. You guys should know how to factor on your own. And then solve this to get negative 3/2 and 4. Okay, but now describing the end behavior. That's using limits. So the limit as x goes to negative 3/2 from numbers a little bit less of our function, and the limit as x goes to negative 3/2, numbers a little bit more than that value of our function. Now, I have a graph of the function to help us out with that. So finding those values. Numbers a little bit less, looks like we're going to a negative infinity. Numbers a little bit more, going to a positive infinity. Now, let's talk about how as x goes to 4. Numbers a little bit less of our function, and the limit as x goes to 4 from numbers a little bit more of our function. So as I start looking at this, numbers a little bit less, numbers a little bit less, we're going to negative infinity. Numbers a little bit more, we're going to positive infinity. It's not always going to work out that the numbers a little bit less are negative, numbers a little bit more are positive. Just so happens in the example I picked, that's what they worked out to be. Okay, our next example. This example I put in here because this is questions that the students had seen similar to this on previous AP questions. So I'm looking for, now I'm going back to infinite limit of e to the x times x squared minus 4x plus 6. Now use limit loss to justify this. As I go to infinity of e to the x, since it's a product of two functions, I can separate my limit out into two products. Now use what your knowledge of graphs are. E to the x. Just knowing what e to the x looks like. E to the x is an exponential function, looks something like that. This function x squared, we know, has the general characteristics of y equals x squared. which is some parabola. I'm just not sure where my vertex is. But I just need to know general characteristics. So general characteristics tell me that as I go to positive infinity of e to the x, what y value am I going to? I'm going up and up and up to positive infinity. Now as I look at the parabola function also going to positive infinity, this function ends up, so I go to infinity, and so therefore this answer would either be infinity or does not exist, because I can't put my finger on a number like infinity. Because if infinity times infinity, really big number times another really big number, is still going to be a pretty big number. But now looking at negative infinity. And notice how I'm able to do these all without a calculator. I'm going to justify my answer with a calculator here in a minute, show you guys that we're right. But notice how each and every one of these I'm doing without a calculator. And that's what my students were expected to do on the AP a couple years ago. Okay, so now I'm going to negative infinity of our function e to the x. What happens as I go to negative infinity? That's an exponential decay function, or it's an exponential growth function, but as I go to negative infinity, I'm getting closer to 0. Even though I'm going to negative infinity, I'm still ending this function up, so therefore this limit is equal to 0. So now let's look at a graph and confirm our answer with the graph. So as I went to positive infinity, we went up forever. As I went to negative infinity, looks like our graph got closer and closer and closer to 0. So we were correct with our two answers. Okay, please make sure your lesson submission is submitted on time.